that you can pretty much type in plain English and it'll understand what you're saying and do what you asked. It doesn't require all the random curly brackets, square brackets that other programming languages need. Or like you guys know in MATLAB where you have to have the start and end or else it screws everything up. You don't need that here. It's all white space based, so like it's all indentation based, and so on. People use Python for web development, software development. Yep, so here's some pros of using Python. It's open source, so meaning if you're a new employee at a company, they don't necessarily have a MATLAB license for you to use or a JavaScript text editor license that you can use because they have to get it approved through payroll, whatever. Python, you just download it off the internet, works right away. It's supported on multiple platforms, so you can have the same code run on a 30 stack server. It could be the same code as you could run on your little Raspberry Pi that you're making a little robot walk. So that's pretty cool. It's high development and high processing with minimal code. It allows for high complexity application development. And it can be run as a backend on things like C#, C++, and JavaScript. And then some big cons of using Python compared to other programs is it's slow for large matrix math compared to MATLAB. So MATLAB stands for Matrix Laboratory. And the entire program is designed around manipulating matrices, right? So it's really good at matrices, not really good at other things. It's like Python's really good at understanding plain English and interpreting what you want to say and making things really simple for the user, but it's not really good at big data sets of matrices. Python is also not necessarily optimized for multi-threaded or multi-processor use. We're not going to cover anything like that today. I just want to bring it up. So like, let's say I wanted to have 2 functions run at the same time. Python, that would be really hard to use, and it uses pseudo multiprocessing, meaning it just jumps back and forth, but it still uses the same core and threading algorithm. But like C#+ or even Linux uses multiple cores in it. Takes advantage of everything. Okay, so as I mentioned earlier, we're going to be using an application called Spyder. And it's just a simple text editor. So when you open your Anaconda Navigator, just click this launch button. And then 3.6. Might take a while. Okay, so just follow along if you don't already have it downloaded and you're just waiting on it. So I like Spyder personally, but there's a couple other you'll notice, like you can use Jupyter or Jupyter Notebook, whatever. Those are all like your Internet Explorer or Chrome-based text editors. So they don't offer the same like live bug checking that Spyder allows. And Spyder is also nice because it has like all the keyboard commands that don't screw up your web browser. So like if I wanted to type something, and then I wanted to comment it out, I could just be on that line and do Control-1 and see how it turned gray, like that. That's obviously not real code, but anyways. Okay, so Python, one of the big things about understanding Python coding is understanding the site package functionality that it has compared to other applications like MATLAB where the functions are just built in, right? So Python has a couple built-in functions like, I'm just gonna get started typing some stuff real quick, try to follow along. So right now I'm just making a list. I'll go over this in more detail in a minute. So like built-in functions would be things like print or length, which is just len. And see how they kind of turn purple? That means the function's built in and you just type it in. There's actually only 74 built-in functions in the Python, and everything else is an extension or site package that just manipulates these 74 functions. So like print or length or sum, basic things like that are all included inside. But a site package, let's say I wanted to take the square root. You guys know how in MATLAB, I'll just jump back and forth between MATLAB so I can show you guys examples. You know how in like MATLAB, you do like SQRT, right? It gives you your answer. Well, if I tried to do that here, it'll give me an error, right? So what you have to do is you have to import a library or a site package called math. So I would come up here, I would call import math, right? And then instead of just square root, I would do math dot square root. And notice when I typed that math dot, it gave me a whole list of things here that are included in that math library. You see that? So you can do a whole bunch of things with that. But that's just an example of something as simple as a square root isn't necessarily included in the Python code without the additional site package add-on. So one of the reasons why I had you guys download Python Anaconda and not just a standard Python interpreter with like the little black and white command shell window is because it comes with all these site packages that you can use. Another great Python package that you can download is called Python XY, and it I think is based on Python 2.7, but it has a lot more applications that come with it, like Qt Designer and a bunch of different script editors. Anyways, kind of jumping back and forth. Are you guys following along? Okay, so I kind of went into site packages, and we'll come back into it later on once I go over a couple other things, so you guys have an understanding of what I'm trying to do. So there's a couple different ways to manage data sets. In MATLAB, you have your matrix or vector or whatever, and you denote it with a square bracket. In Python, there's a couple of different ones. You have a list, a tulip, an array. Actually, it's called a tuple. I don't know why I said tulip. Dictionaries, and so on. So a list is essentially just a vector or matrix or however you want to look at it. You denote it. So I'm going to type list1. I'm going to assign a list to the variable list1. Make sure you put the number 1 or else it'll turn purple and it'll think you're calling the list function in Python that's built in. So list1 is equal to 1, 2, 3, 4. And something that's really cool you can do in lists is you can have a list within a list. Oh, is this? Let me try to zoom in. There you go. Everyone can see that. Perfect. Saw some squinting eyes. You can have a list within a list, right? So I can just do another square bracket there. And your list doesn't actually have to contain all the same types of variables. Within this list, I can have text, or what's called a string, say. Right? Does that make sense? And then, just for example's sake, I'm going to come down here. I'm going to print list1. And then if you haven't already, click this green arrow, and it might ask you to save it. Save it on your desktop. You can delete it later. Okay, great. And see in the bottom right corner, it just printed your result. So equivalent to this window, this entire application to MATLAB, is this lower right corner would just be kind of like your command shell window, your command window, right? And this left side is your script editor that's up here. Make sense? I should have gone over that a little earlier, but you guys seem to be smart enough to realize that. Okay, so you can also call certain elements of a list, just like how you can in other applications like Java or MATLAB. So I can call list of index 0. So a big difference of Python compared to other applications or other software languages is it starts on indexes of 0 instead of 1. MATLAB starts on 1. Python starts on 0. So this value 1 that's in the list is actually indexed at 0.0. So if I call list1 of 0, then I'll get the value 1 returned down here. You see that? Cool. Well, what if I called 0, 1, 2, 3, 4? What if I called the index of 4? Yeah, it'll just print this secondary list, right? 1, 2, 3, 4 there. I hate how I wrote 1, 2, 3, 4. I'm sorry about that. It's kind of confusing that I have it there twice. But it can really be whatever number. This can be 5, 7, whatever, 8, and it changes. Well, let's say I wanted to call this 8 value right here. Well, then I would, after the square bracket, I would just do another one. That. I'll click run, and then I get my value 8 returned down here. Cool. Relatively simple. It's pretty similar to other programming languages in that sense. By the way, guys, I could be doing all of this down here in this IPython console or command window, however you want to, whatever you want to call it. But I'm just choosing to do it in the top left because I can zoom in and have multiple lines that way. Okay, and if I wanted to go in reverse, I would just use negative numbers. Right, so like if I wanted to print this string, I would just print -1. Right, to count backwards, just go negative. There you go. Cool. Awesome. Lists are one of the most powerful tools that you can have in Python for managing data. You can add to a list, you can edit it later on, which is pretty cool. A couple other data sets or data types in Python you can't edit, like a tuple, you can't edit after you create it. And that has its benefits for other reasons, and I'll go over that in a moment. But another thing you can do in Python, I'm just going to kind of edit the code that I have. I know this isn't good for you guys taking notes, but it's easier for me. So I can say, if I wanted to edit, I would just say list1 of some value, and then I could just set it equal to something else. Apostrophe, that's the word. Use apostrophes to denote a string or a list of letters. Right, so I can just do that, and then it'll change this value. So this value was 3 here, right? But then I changed it to a different value. Okay, and you can see it changed down here. And you can't necessarily do that with tuple or other data sets. Cool? Awesome. So I'm going to just kind of move down. I'm going to comment all this stuff out. So I'm going to do Control-1 to comment it out. That way you guys can still see it, but I don't want it to run anymore. I'm over it. Okay. So actually, let's start with arrays. Okay. So an array is essentially the Python equivalent of a matrix in MATLAB. So you guys know in MATLAB, if I had like a matrix, right? And then I could just say A divided by 3, and it would actually divide each element by 3, or A dot divide, depending on like if it's in your script editor. You can't necessarily do that in Python. So if I have A equals, a list, whatever's in my list, and I said print A divided by 5. It'll give me an error. And it can say you can only divide numbers that are an integer, right? So what do I do about that? If I really don't want to say write a whole for loop and say for each element in the list A, add 1 or divide 5 or whatever you want to do to your list, what you can do is you can import a pretty helpful math toolbox called NumPy. So I'm going to just type import NumPy, right? And you can choose it. You can choose to throw it in parentheses if you wanted to. In a lot of other programming languages, you would have to, but since Python uses an interpreter instead of a compiler, you don't need to do that. So I'm going to import NumPy. Then I'm going to say A equals NumPy.array. And I'm going to take my list and throw it into an array. Right? And I could have also just said B equals NumPy.array of A if I wanted to do that, and then, but I don't want to do that. And there, now it worked. See that? So that's a pretty helpful tool if you want to change a lot of elements in a matrix or all the elements in a matrix without making a whole for loop, because that takes a while to not only run, but it takes a while for you to code, and it's a headache. More lines, whatever. So this is a great way around that and to get the MATLAB equivalent of an array in Python. Any questions? All right, so we're going to move off of arrays. That's pretty much the basis of arrays that we're going to cover in this workshop, but you can do a lot more with them if you so choose to. The internet's a great resource. There's actually, from what I've seen, there's a lot more documentation on Python than there is other programming languages out there. Maybe Java and C++ have similar amounts of documentation, but it's certainly more than MATLAB, certainly more than C#. So that's one of the big benefits. So if you have a question about something, or you're like, oh, I can't figure this part out, just Google it. And then websites like Stack Overflow or GitHub always have a lot of great helpful answers for you guys. Obviously we can't cover everything about Python in an hour or even 5 hours. You just have to work with it to learn it. And if you need to learn more things, then you can Google it. Cool. All right, so next we're going to cover tuples. And a tuple is a list that you can't edit afterwards. So essentially, the benefit of using a tuple is it's like a save. So if I wanted to make a copy of a list and then I wanted to edit the copy, what happens is it edits both the copy and the original list. It's really annoying. So what you can do is you can create a tuple. So I'm going to say tuple1 equals, and instead of square brackets, we're just going to use parentheses. Tuple1 equals 1, 2, comma, tuple. And it has the same rules. You can have a list within a tuple if you wanted to. I can just throw some square brackets in here. I don't believe you can have a tuple with a tuple. I actually don't know the answer to that. Let's try it. Yeah, I guess you can. You can have a tuple with a tuple, or you can just make it a list if you wanted to. So I could have done this, or what I could have done is just had all this stuff. Oops. I keep throwing a 1 at the end of it because if I don't, it turns purple and then it gets confused because it thinks it's a function. And I can say tuple1 equals, or I'll just say tuple2 equals, I'm going to use the tuple function that's built into MATLAB. So it just converts the list into a tuple for you. Right? So that's a great way to save your list if you're editing them within a function. But let's say you have a user interface and you're allowing the user to edit data sets, but you don't necessarily want the user to screw over your entire program or your job or whatever. Well, that's when you would use a tuple because you're not allowed to edit it. So if I came over here and said tuple2 of 0.2, I want to set it equal to 0. Well, it won't let me do that. It says tuple object does not support item assignment. Right? So once you create it, you can delete it and remake it, but you can't edit it afterwards. So it's a pretty cool tool. Any questions so far? All right, so I'm going to cover one more type of data management, and then I'm going to move on to cool things like if-else statements, loops, and that's when Python really becomes beneficiary to use over other programs. So I'm going to do what's called dictionary right now. And dictionary is just what you might think of. So you want to look up what a word means, you open the book, you find the word, and then right next to it, you find what the word means, right? So I'm going to make a dictionary, call it this, dictionary is equal to, and instead of parentheses or brackets or square brackets, you use these curly brackets, right? So I'm just gonna, you can put them all on the same line if you wanted to, but just for easy reading and so I don't go off the page, I'm gonna do multiple lines. Do brand. I'm going to make car names, okay? Brand, and then colon, and then my favorite company in the entire world, model, another colon, Mustang, comma. Don't forget the comma, guys. This is one of the only instances where pressing enter instead of a comma does not work. It's actually really annoying because everything else in Python, you don't need commas or semicolons or whatever. But for this specific thing, you do. It doesn't work like MATLAB where you can just do a space instead of a comma, separate values. Anyways, I'm going to do one more. I call year. Oops. Oh, I can't spell today. 1964. Okay, so I have my dictionary, right? So the benefit of this is instead of calling an index of a list, which I may not know what the value is, I can just call the name, and then it'll return the item or the definition of that name that I just called. So I'm going to go ahead and I'm going to print it so you guys can see it. Print this dictionary of brand, right? And it returned the word Ford. Pretty cool, right? I've personally never had to use this, but I thought I might as well go over it because it was the only one I didn't cover so far. Everyone get that? Go ahead and comment this out real quick, but I'll still leave it up there if you guys want to copy it. Okay. Next thing we're going to cover is an if-else statement. You guys have used if-else statements before. If you have any programming experience at all, I hope you've used it because otherwise, I don't know what you're doing. So you really don't need parentheses again for these statements because it's an interpretive programming language. So I'm going to say A equals 100, B equals 200, for example. And I'm going to do the standard if A is less than or equal to B. Colon. You do need colons because otherwise it doesn't know when you finished writing the if statement. I'm going to say print A is less than B. Okay. Come over here, Shift Tab to go back, or you can just hit backspace a couple times. Else. And B is less than A. Okay, what do you guys think is going to happen? Okay, well, let's just see. A is less than B. Thanks for your enthusiasm, I appreciate it. Cool. Well, let's say I don't want to write 5 lines of code, and that's ridiculous, and I don't remember the specific notation because well, Python's an interpretive programming language, so I can just type it in plain English. So I'm going to say print A is less than B. A is less than B, and then just space if A is less than B. Else, print B is less than. Cool? Wow. It's almost as if I don't need to remember notation when you use Python, and that's true. It actually did it twice because I ran this, but turns out A is less than B. Cool? Awesome. All right, so that's one of the big pros of Python is it's completely interpretive. Great. So any questions on if statements in Python? Cool. All right, so we're gonna move on to loops. First, we're gonna do a while loop. Two main different kinds of loops. You got while and for. While is mainly used if you want to add non-integer values. For is mainly used if you want to go down the list of or go down a list, index by index. So for counts by ones, while counts by whatever you want, right? But you can use while for all for, but not for all while functions. That probably doesn't make sense. But anyway, so let's start. I equals 1. Cool. While I is less than 6, print I. And then at the end, if I don't want this to run forever, because what will happen if I just run this right now? It'll just print 1 forever. And then my computer will be like, why'd you do this? So I'm going to do I equals I plus 1. Another cool notation, and I actually didn't remember this until I re-looked it up, to be honest. It's I plus equals 1. So that's just saying add 1 to I. I'm pretty sure C++ has that as well, but I'm not completely sure. Cool. So it's going to print 1 through 6, 1 through 5. Now it'll print 1 through 6. Does that make sense, guys? Simple for function. And once again, I could make this happen in one line if I did a for function. Let's say I had a really complicated loop, right? And I didn't know if it was ever going to break. Well, in here, I could throw a simple if statement in here and say, if the number of iterations is huge, break the loop so you don't crash your computer, so you don't run out of memory, so on. So I'm going to say, for this, I'm not going to write a really intensive function really quick. But you guys, I hope you will understand the concept that, sometimes depending on your inputs and outputs, the loop may not ever finish with simple logic. But you can just throw some other simple logic in here. If I is equal to 3, oops, type break. It turns blue, so it's one of those built-in functions. And it'll just break the loop. So what do you guys think will happen when I run this? Yes, good job. Did it. Great. Awesome. You guys good on whiles? While functions. I'm going to gray this out. Oops. Whoa. Any questions so far? Wow, that must be really good. All right. So I'm going to make a list called fruits. And inside of the list, I'm going to name some fruits real quick. Apple. What's one of your guys' favorite fruits? Yep. There we go. Okay, so instead of doing this while function, because it kind of took a lot of lines, I had to do the I equals 1, and then I had to do the I equals I plus 1. That's 2 unnecessary lines that I don't care about. I don't want to write them. I'm lazy, whatever. If you're running a really long loop, it actually makes a significant amount of time difference if you don't include those 2 extra lines. Because since Python has an interpreter and not a compiler, it has to interpret each line and try to figure out what you want from it. So instead, I'm just going to say for I in range of length fruits, print fruits of I. So the range function, and we'll go over this in a couple of minutes. I just kind of threw it up there. But essentially what the range function does is it creates a list of like 1, 2, 3, 4, 5. In this case, it'll be 1, 2, 3. So the length gives me the value 3, and then the range creates the list 1, 2, 3, right? 0 to or 1 to 3, and then this for I in range, or this for I in, it just goes through that list that I just made from this range function and prints that value. Cool? There we go. Apple, banana, me. I'm fruit. Okay. Well, just to kind of describe what this range function is doing, I'm going to come over here and I'm going to say list1, recall list1, and I'm going to say is equal to 1, comma 2. Let's do that. So instead of writing out this whole thing, let's say I didn't want to call the fruits. Let's say I wanted to call every other fruit. Well, then I would just say for I in list1. It only printed index 1 and 2. Well, I could say just 0 and 1, right? What happens if I have this value after? It'll change the order up. Cool, right? Thanks. Appreciate it. I think it's cool. You guys may not, but whatever. All right. Ooh, functions. Functions are my favorite. So defining functions in MATLAB is very similar to how you would in C or C++. You know how you type, have you guys used Arduinos before? Some people have. So when you're writing Arduino code, you write DEF and then the name of the function, because it's just C++ that you're writing in. It's the same idea. So I'm going to gray all this out. I'm going to do a quick example. So I'm going to make a function that all it does is add my two inputs together. So I'm going to have two inputs, X and Y. I'm going to start out by typing def, and it turned blue. So I'm defining a function. I'm going to say def addition example. This is the name of the function. I'm going to say my two inputs are X and Y. Right? Just how you would in any programming language when you define a function. So I'm going to say z equals x plus y. I'm going to have it return. I actually don't need a space there, or a colon. Return z. So what I have to do now is I'm going to type my function. I'm going to print it out. Print addition example. What number should I use? 4. What else? 28. Okay. So what's going to happen? I'm going to print this. Wow, 32. Didn't expect that one. Okay. Now let's check on something. Do you guys think, without looking, do you guys think z is going to show up on this variable explorer? No, it's not. Someone shook their head. I was just pointing into the line. It's not going to show up on the variable explorer, and that's because I only define z within this function. So something really cool about Python is I can say z equals 100. I can run this addition example, and I just want to print z. which z do you guys think this is going to return? The 100 or the, what number was it, 32? It's going to print the 100, right? And is not going to mess with this function at all. It's pretty cool. Well, let's say I did want it to mess with it. So now I'm going to introduce the idea of a global variable. And a global variable, you can pass it between classes. And I'm not going to cover that during this lecture, but essentially a class is a function of functions, pretty much. You know how when I typed math.square root, right? The class is math, and then the function is square root, for example. That's actually not entirely true, but it's a good way to think about it. All right, so it printed 100. So let's say I come down here. I would say global z. So I'm just defining my variable z as global, and you do have to define what kind of variable it is before you assign it. And then I have to do the same thing within this function. Right, so it knows I'm talking about the same z. Because even if I define global z up here and didn't define it in the function, it'll still think it's talking about a different z value. Right, but now, what value is it going to print? Does anyone know? $32. There you go. Good job. Does that make sense to everyone? It's actually a very powerful tool. I know this example is pretty elementary for you guys, and I know you've worked on a lot more complicated tasks doing your own stuff, but if you can imagine using a function in the first place, these global variables are extremely powerful because I didn't want to input, if I wanted it to work with this z value that I created, I didn't want to input another input, you know, for example. So let's say I'm going to edit this example a little bit. So I'm going to leave z as 100. I'm just going to skip that part. I'm going to return x plus z. And I'm only going to have one input called x. So this is one of the main reasons global variables exist, is so I don't have to have this additional input, right? Because if you can imagine writing a function with a bunch of different variables, or where the user inputs like 6 different matrices at the same time, you don't want to recall the same function or a bunch of different functions with all these inputs, because then eventually your list of inputs is going to be like a million, and it's just going to be ridiculous. So if you have, it's better to have a million global variables than it is to have a million inputs. That way you don't get lost in which variable is which, and so on. Right? Cool. All right, moving on. I feel like I beat that one to death. Another cool thing you can do in Python that you cannot do in MATLAB or JavaScript is something called recursion. And I don't have a specific example on hand for that, but that just means that I can call my addition example within my addition example. So I can just say if x right? I know this example sucks. It doesn't make any sense at all why I'm doing it, but this is something that you can do. You can call the same function within that function itself. You do have to be very careful, though, not to send yourself into an infinite loop. If I called, actually, this wouldn't send me into it. If I did this, it will send me into an infinite loop, Let's just do it. Just kidding, I'm not going to do that. If you guys do send yourself into an infinite loop, see where my mouse is over here? This gray box. It turns red when something's running. You just click that, it stops it. So you don't crash your computer, run out of memory, so on. It's kind of amazing how fast you can run out of memory. Anyways, okay, does that make sense, guys? Recursion. Awesome. All right, so now I'm going to do a plotting example because as an engineer or a scientist, you do have to do a lot of plots and everything. And you know what? While I'm at it, let's bring in some external libraries like NumPy. We're going to be using one of the most popular Python plotting packages. It's called Matplotlib, M-A-T-P-L-O-T-L-I-B. And then we're going to use a function as well. Cool? So let me gray all this out. Kind of done with that stuff. All right. So now over here, I'm going to import NumPy. So let's say I don't want to type NumPy every time. It's kind of an ugly word. I don't like it that much. It's 5 letters. It's too much. So I'm going to type as NP. So now I'm calling this entire library NP instead of NumPy. Right, and you'll see in a second that that tool is actually pretty useful as well, especially when you have multiple dimensions of libraries that you're using. Like remember when we did math.square-root? I could import math.square-root as SQT, right? Because it's shorter, and I didn't have to type math.square-root. If I was doing it a bunch of times, and it's just easier. Sometimes you have to do it like that, depending on your application. So I'm going to import the entire library called Matplotlib, and specifically a subclass called PyPlot. So .pyplot. I'm going to call it as PLT. So instead of typing that long matplotlib.pyplot, I could just type PLT instead. Okay, so I'm going to define function, plot example, and let's see, what kind of graph do I want to make? I'm going to do a sine function, and I want my 2 inputs to be where my sine function starts and where it ends. Cool? Okay, so start, end, those are my 2 inputs. I could just do S and E if I wanted to, or 1 and 2, but I'll do start and end. So I'm going to make my time scale first, and I'm going to, you guys remember in MATLAB, the linspace function? So your start and end and the number of points you want in between. So MATLAB, well, NumPy has the MATLAB equivalent of that, and it's also called linspace. So it's np.linspace, and you can see it popped up right there as soon as I started typing. So I'm going to do my start, my end, and then how many points do I want in between? Okay, I was going to call that T. I could make it X if I wanted to. It doesn't really matter. Oh, another thing you guys may have noticed is you see how it's not printing out every time I define a variable and I don't put a semicolon after it like it does in MATLAB. I honestly hate that. Like if I have like a really long list that I'm making and then I forget to put a semicolon after, it'll crash my computer just rewriting the list. It's freaking ridiculous. But you don't have to worry about that here. But if you like that, I guess you can just print it out every time. So NumPy also has a sine function as well. It has a bunch of different packages with it. So if you guys come across where you don't remember the name of a function or something, you can just Google it. It's easy. You're obviously not going to remember every function that I went over today, and I'm not going to go over every function that exists. So that's what it is. So I'm going to plot, or I'm going to do plt.plot. So you guys can see where it would get really long if I didn't do this import as, because I would have had to type matplotlib.pyplot.plot. It would just be ridiculous. So I'm going to plot. It's the same way you plot x and y. And then, oops. Call this time. Okay. So in other programs, you don't necessarily need this last line, but in Python you do, because once it shows it, then you can't edit the plot from the script afterwards, right? So what will happen is if I run this command shell and I had plot.show up here, then the X label and Y label wouldn't show up. So I have to define all these different things before I show or print the function, print the plot. I feel like 1,000,000 is kind of overkill on this. Might make it 100,000 in a second. We'll see. I'm gonna do a 515. I could even do 0 to np.py. Right? Oh. Yes. Yes, there is a np sign in degrees. I think it's d, sign d. Here, let me see. No, not sign d. I know it exists though, and you might have to use a different library for that exact functionality, because remember math, if I had import math, math also has the sign function as well. Okay, so I'm going to do this, see what happens. Uh-oh. How about this? Just going to do my 1,000,000 data points. Yeah, there's your sign function. That makes sense? So you guys may notice that this is really small over here, and especially if you wanted to give this on a report. So what I would do is if I save this script and then I just double clicked on it, then it would just print the plot separately in its own window. And matplotlib has a lot of its own functionality. Like you can edit the title and stuff afterwards in that window that you printed in. You guys know how in MATLAB, when you plot something, it pops up with a separate window and you have all the tools where you can like scroll over it and edit the curvature of the line, whatever you want to do, edit the title. Matplotlib has the same thing. And there's, you're not stuck with the same graph format that you are in MATLAB or other plotting languages or other plotting programs. Because Matplotlib isn't the only plot graph option that Python has. There's a bunch of them, which is really cool. You're not limited to just what the one developer wanted who works at MathWorks or Microsoft, whatever. Okay. Does that make sense to everyone? We have a couple minutes left, so I'm just going to cover some limitations really quickly that Python has that other programs don't have. Does anyone have any other questions before I start wrapping things up? Great. Okay. So remember I mentioned Python has an interpreter that goes with it that allows me to write in plain English pretty much. That actually takes a lot of processing power to handle, and it makes it a lot easier for the person who's writing the script, but it's not necessarily easier on the computer. So what you can do is, I'm not sure if Anaconda has the availability to do this, but I know for sure Python XY does. is you can just compile your code, just how you would in any other programming language. Like when you're writing an Arduino code, like on C++, and you click upload, first it compiles it. So it takes like 20 seconds to compile or however long your code is. And then it sends it to the Arduino as machine code. So the Python compiler will do the same thing, but on your own computer. And it'll make it run a lot faster because then you don't need that interpreter to interpret your language anymore. Does that make sense? So the interpreter is really good if you're live editing and running and then go back to editing and you have a lot of problems in your code and you're like, oh my God, what's going on? And then you don't want to wait 20 seconds every time you run it. Then it's really good. But if you want something to keep running over and over again and you want it to be fast, like as fast as possible, that's when you would use the compiler. But that's not automatic. That doesn't necessarily come with every site package that MATLAB offers. All right. I mentioned the matrix issues that Python has compared to MATLAB. There's a way around it using np.array, and I brought that up earlier. But if you're using really large data sets of matrices, MATLAB's your way to go. If you're trying to integrate other programs or you just don't have MATLAB, Python's the way to go. Or C++. We're not covering C++. But, yep. Python also has a limitation in multi-processing, so using multiple cores of your computer at the same time, multi-threading. Since Python is designed to run on a huge variety of different things, like I can run Python on my phone, on an Android. I can run Python on a Raspberry Pi, on a giant server rack. So the developers of Python couldn't figure out, I mean, they probably did have a way to do it, and there is now a way to do it. But if they wanted the same code to run on every machine, then you couldn't have true multi-core processing, multi-thread processing, like you can have in Linux or C++ or even Java. But you can do pseudo multi-processing, and it is slightly faster than running both things in order. And it just runs back and forth between each line of the two processes you want or the three processes you want. So it'll go this line, this line, this line, instead of this entire thing, this entire thing, this entire thing. Does that make sense? Cool. I mean, that's pretty much it. There's some more applications that you can do, and I'll be sending out an email in a couple of days to rate me because I have to. But Python can also be used to streamline communication between other onboard applications. Like, let's say I wanted to, here's a terrible example. Let's say I'm Microsoft and I'm designing Microsoft Word. Okay, so I want to make my front end where the user types the Word document in C++, and I wanted to have my back end in Python. I could do that. I could have two separate applications talking to each other. And you can't do that in MATLAB. So like if you're making a professional application and you don't want someone to have MATLAB on their computer or have to look at your code every time they run it, then you can make a quick Python application and have it talk to a C# application, C++ application. And the way to do that is called Python Qt. And that doesn't come with Anaconda, but it does come with XY if you're interested. And I can hold another workshop just teaching that and the basics of that, because that's something very helpful, especially in a professional environment where you don't want to send someone just your code. You want to send them the completed application where you're done with it, and it's very user friendly. There's just like two buttons instead of you have to go edit the code, yes or no or whatever. Python has easy integration between server and satellite computer applications. So like, let's say I wanted to have my Arduino talk to my computer. I could do that really easily with Python. There's ways to do it in other programming languages as well. But it's pretty straightforward in Python. Have you guys heard of OpenCV, the image processor? It's open source. Another cool thing you can do with Python is you can just download the OpenCV package for free, and I can do live facial recognition of everyone with Python for free. That's just an example. Or for, I'm an aerospace engineer. So like if I was doing image processing of an airplane, I could do that. And I wouldn't need to download a $10,000 software and buy all these cameras and everything. I could get my webcam in Python and OpenCV for free. I could do the live image processing right there, real time. Yeah, that's pretty much it.